So we will start the questions of simple harmonic motion. Set 1. Question number 2. The displacement of a particle varies with time according to the relation y equal to the displacement of a particle varies with time according to the relation y equal to capital A sin omega t, capital A sin omega t plus capital B cos omega t, capital B cos omega t. Option A, the motion is oscillatory but not SHM. The motion is oscillatory but not SHM. Option B, the motion is SHM with amplitude. Motion is SHM with amplitude A plus B. Option C, the motion is SHM with amplitude A square plus B square. Option D, the motion is SHM with amplitude root over of A square plus B square.
Option D, sir.
Option
D.
Because it is a combination of two SHM. One SHM is given by capital A sin omega t, other SHM is capital B cos omega t. So addition of or superposition of two SHM is always an SHM with amplitude root over of A square plus B square. So option D is correct. Question number 4. Out of the following functions, representing motion of a particle, out of the following functions representing motion of a particle which represents SHM, which represents SHM. Function 1, write 1, y equal to sin omega t minus cos omega t. Number 1, y equal to sin omega t minus cos omega t. Number 2, y equal to sine cube omega t. Y equal to sine cube omega t. Number 3, y equal to 5 cos bracket 3 pi by 4 minus 3 omega t. 3 pi by 4 minus 3 omega t. Number 4, y equal to 1 plus omega t plus omega square t square. 1 plus omega t plus omega square t square. Now, option A. Only 4 does not represent SHM. Only 4 does not represent SHM. Option B, 1 and 3. Option B, 1 and 3. Option C, 1 and 2. Option D, 1, 2, 3. D.
1 and 2 is
Why not D?
because there is no sine and cosine. No sine and cosine here.
Acha, sine cube is there. If you consider the option 2, then there is a sine cube term. But it can be converted to sine. Because you have this relation that sine 3 theta equal to 4 sine theta this type of relation is there. Sine 3 theta's relation 4 sine cube theta minus 3 sine theta, 3 sine theta minus 4 sine cube theta. I forget the exact relation. Something like this. Sine 3 theta equal to 3 sine theta minus 4 sine cube theta, like this. So from that I can write sine cube theta equal to theta equal to 3 sine theta minus sine 3 theta by 4. Now theta can be substituted as omega t. So sine cube omega t equal to 3 by 4 sine omega t minus 1 by 4 sine 3 omega t. Individually these two are also SHM.
Option C, sir. Option C, because option number 2 and option number 4. Option number 2 is a periodic function. It doesn't represent the simple harmonic functions. And then option
2.
Answer is option C.
Option 2 is sine cube omega t. But sine cube omega t can be represented as a combination of 2 SHM. And sum of 2 SHM is always an SHM. Why not 2? Your answer is correct. But solve this. But tell me why this is not correct. Only 1 and 3 represents SHM, not 2. But if I use the multiple angle formula, then I can write that sin 3 theta equal to 3 sin theta minus 4 sin cube theta. Then from that I can write sin cube theta equal to 3 by 4 sin theta minus 1 by 4 sin 3 theta. But theta is omega t. So both are representing two SHMs. So combination of the two SHMs are also SHM if I argue from that. This one is SHM. This one is another SHM. And the linear sum of any two SHMs is also an SHM. From that, if I argue that this function is representing a simple harmonic motion.
Phase should be same. Phase should be same.
Phase should be same. This argument is different. See, this is omega. This is 3 omega. So their combination is not always an SHM. Their phase should be same. Previous problem, just see the previous problem. Sin omega t, cos omega t. There is no cos 2 omega t or anything. 3 omega t, not like that. So as long as this phase angle should be same, then you can consider that some of them is representing SHM. But here one is omega t, other is 3 omega t. So their combination will not represent SHM. Individually they are SHM, but their combination is not an SHM. Okay. So they should be of same frequency. Here frequency differs actually. Omega differs means frequency differs. Frequency differs if you add them, then it is not an SHM. Okay. You have already studied this portion. That combination of two SHM having different frequency is not an SHM. In which topic? Bits formation. Two waves differing by frequency, when they superpose together, they will produce beat. And in beat, amplitude is a function of time. That's why we can hear the loud sound after a regular interval. So if the amplitude is depending on time, then it is not a proper SHM. Two different frequency SHM superpose and producing beats. That's why the amplitude of beat is a function of time. Since it is a function of time, you cannot say the resultant wave is a simple harmonic wave. So only 1 and 3, these two are representing SHM. So option B is correct. Okay. Another question, but that is not in the book. X equal to cos square theta. X equal to 2 cos square theta. Okay, sorry, 2 cos square omega t. X equal to 2 cos square omega t. Is it representing an SHM? If so, find its amplitude and frequency. All units are SI. Find its amplitude and frequency. If it is an SHM. If not, then nothing to find. You have two ways to solve this problem. Either this equation is reduced to linear equation from the quadratic cos square is there. So you can convert it to linear equation and then try. Other method is differentiate it twice with respect to t and find acceleration and check whether acceleration is equal to minus omega square x or not. Acceleration is proportional to minus x or not. Means restoring force is coming or not. Derivative of 1 will be 0 and it will be my cosine function derivative will be minus sine 2 omega t and 2 omega is coming out. Okay. Then again calculate the differentiation d2x dt2. Another 2 omega will come out, so it will be 4 omega square. Then it will be cos 2 omega t. Okay, but what is cos 2 omega t? Cos 2 omega t means x minus 1. So you can put here d2x dt2 equal to minus 4 omega square into x minus 1. Okay, minus 4 omega square into x minus 1. Now, can I write this one in this way? d dt d2x dt2, but I write d2 dt2 of x minus 1 because derivative of 1 will be 0. So it will give you the same term. Then I will define x minus 1 as a new variable, say y, or any x1 or anything, x1 suppose. So it will be minus 4 omega square x1. So it is performing SHM, but the equilibrium point is not x equal to 0. Equilibrium point is x equal to 1. About x equal to 1, it is vibrating. So because there is a constant term, the equilibrium position is shifted from x equal to 0 to x equal to 1. So about x equal to 1, it can perform the SHM.
Sir, once more.
If it is coming d2x dt2 equal to minus omega square x, then it is performing SHM about which point? About the origin. Then if it is x minus 1, then it is performing SHM about a point for which x minus 1 should be 0. So about which point it is performing SHM? X equal to 1. Because you can consider this is a cosine function coming. So you are considering that about this point the particle oscillates. If you consider that about this point particle oscillates, say at this point, is the graph not representing SHM or not representing cosine function? Still it is representing cosine function. You can shift the origin. Only there is a change in the origin. That means phase is changing. But that does not mean that cosine function is changed to some other function. Okay, so it is still an SHM. But the oscillation is not with respect to the origin. Equilibrium position is somehow shifted. And about that point it is oscillating. You can consider one example of this. Suppose there is a vertical spring. From that spring, put some mass, okay, and hold the spring. And due to this mass, there is a elongation. And suppose at this point it is elongated, and consider that point is y equal to 0. About this, if you pull suddenly and release, it will start to oscillate. So about which point it is oscillating? About y equal to 0. Now suppose you put another amount of mass with this mass attached to this mass. So equilibrium point goes down. Suppose it goes to x, or you decrease some mass. So equilibrium point will not be at y equal to 0. Because this mass is decreased, so equilibrium point slightly shifted up, say y equal to 1. Now again pull it and release. So about which point it will oscillate now? y equal to same thing. About y equal to x equal to 1, it is now oscillating, but still representing an SHM. Only the origin equilibrium position is shifted. Okay. So don't go for the derivative when this type of quadratic function or anything is given. Directly convert from the multiple angle formula to check whether it is SHM or not. There is a question that is coming in ARPMT 2010. X equal to given a sin square, don't write, x equal to a sin square omega t, and they are asking for the frequency of the SHM, the same type of problem. You have to convert and find the frequency. Write one more question. If the length of a simple pendulum, is increased by an amount, its time period increases to t1. Its time period increases to t1. Means its time period becomes t1. If the length is decreased by same amount, the time period will become t2. Then find the time period of the original pendulum. Time period formula you have to use 2 pi root L by G. See, answer will be in terms of T1 and T2. In terms of T1 and T2. In combination of T1 and T2. See, suppose there is a simple pendulum of length L, then its time period T will be 2 pi root over of L by G. Now it is mentioned that if the length is increased, let us consider length is increased by an amount x. So new time period will be t1, that will be 2 pi root over of L plus x by g. Then if the length is decreased by same amount, then t2 it will be 2 pi root over of L minus x by g. Okay, then this x is not in that expression, so we have to eliminate x to find the t in terms of t1 and t2. So I can write by squaring and adding these two, that 4 pi square by g into L plus x plus L minus x, because 4 pi square by g will be in both the terms, so it is common, then it is L plus x plus L minus x, so x will cancel. So from this you can write t1 square plus t2 square equal to 2 L will come, so I will write 2 separately, and 4 pi square L by g separately. Because 4 pi square by g already there, and here is coming 2L, so I write 2 here, L here. And calculate the square of this first expression. It will be t square equal to 4 pi square L by g. So you can put this bracketed term as t square. So it will be t1 square plus t2 square by 2 equal to t square. So this time period of the original pendulum is root over of t1 square plus t2 square by 2. This is the answer. With time period capital T. Then how much time the bob will take to travel from the position, travel from the position of half of the displacement, half of the maximum displacement, travel from the position of half of the maximum displacement to the position of maximum displacement. Okay, the question is this one. This is a simple pendulum bob. Suppose it oscillates between these 2 points. This is the maximum width of the oscillation. Now it will consider that at this point x coordinate is 0. So it goes from this point. This is the displacement, half of the maximum displacement, to this point, that is maximum displacement. This is maximum displacement position, maximum displacement, and this is half of the maximum displacement. Then you have to find the time to travel this part. How much time it requires to travel from half the maximum displacement to maximum displacement. can consider that the equation of this SHM is like x equal to a sine omega t. We consider that it starts from x equal to 0. So note their additional phase pi is taken. So x equal to a sine omega t. Now maximum displacement means amplitude. Half of the maximum displacement means amplitude by 2. So let us consider from this x equal to 0 up to this, it takes time t1. In coming from x equal to 0 to half of the maximum displacement, it takes time t. Then from this we can write this t1, value of t1 I can found a by 2, x equal to a by 2, it is a sine omega t1. This a will cancel. So this is half. Half means sine 30. 30 is pi by 6. This is equal to sine omega t1. Then we can write pi by 6 equal to omega means sinusoidal function. I thought that I cancelled that 2 also. So whenever you are trying to solve this problem, use this sinusoidal function to solve. Otherwise, if any other point is given where the amplitude is suppose 3a by 2 or like this, then you will can face, or 2a by 3 or a by 4, then you can face the problem. But if you start from the sinusoidal function, then you can calculate properly. Otherwise, you have to remember that for this zone it will be t by 6, for that zone it will be t by 2, etc. Because I am giving two symmetric values, that one is a by 2, another is a. But if it is somehow here, which is not exactly at the middle of the half of the amplitude, then what you will do? Then from that you have to use that general method to solve the problem, that finding t1 and t2 and then take the difference of time, that is t2 minus t1. Write down question number 15. The amplitude of a particle executing SHM is 4 cm. Amplitude of a particle executing SHM is 4 cm. At the mean position, the speed of the particle is 16 cm per second. At the mean position, the speed of the particle is 16 cm per second. Centimeter per second. The distance of the particle from the mean position, the distance of the particle from the mean position at which the speed of the particle becomes, at which the speed of the particle becomes 8√3 centimeter per second. 8√3 centimeter per second will be option A 2√3 centimeter, option B √3 centimeter, option C 1 centimeter, option D 2 centimeter. So how to solve this one? You have to use this form, that V max equal to omega E. From that, first calculate omega. Omega will come 4. Radian per second. Then use this formula that V equal to omega root over of a square minus x square and pi. G is given 8 root 3. A is given omega you find, so you can find x. It will be 2 centimeter. Question number 26. A particle executing SHM with maximum acceleration alpha and maximum velocity beta. Then its time period will be option A, beta square by alpha square, option B, alpha by beta, option C, beta square by alpha, option C is pi beta square by alpha. Option C is pi beta square by alpha, and option D is 2 pi beta by alpha. 2 pi beta by alpha. The maximum acceleration alpha is omega square capital A. Maximum velocity beta equal to omega A. You can divide these two to get alpha by beta equal to omega. Okay, but omega equal to 2 pi by t. So t will be 2 pi beta by alpha. Total mechanical energy of a particle is constant. Total mechanical energy of a particle is constant. If its mass is m and velocity at a point, at a position, velocity at a position is v when its potential energy is kx square. Potential energy is kx square. K is a constant. Then find its frequency, natural frequency. Find its natural frequency of oscillation. Find its natural frequency of oscillation. See, it is given that total mechanical energy is constant. Total mechanical energy means kinetic plus potential. So I can write half mv square plus potential energy is mentioned in the problem kx square, not half kx square. Then it is equal to total energy, which is a constant. This one is constant. So differentiate both sides with respect to time. Then it will get half m 2v dv dt plus k into 2x dx dt. But what is dx dt? V. And its derivative will be 0 because total mechanical energy given constant. Now I can write from this that these two will cancel, one v will be cancelled, then it will be m dv dt means ma equal to minus 2 kx, ma equal to minus 2 kx, or from this we can write a equal to minus 2k by m into x. Now compare it with the SHM equation. Omega square equal to 2k by m. This v, this one is k into 2x into v. By taking v common and this side there is 0. So first term will be m dv dt is acceleration, and this term will be on this that side it will be 2k x. V is cancelled from both sides. See, after cancelling 2, it will be mv dv dt, and this term taken on that side will be minus 2kx v. I cancel v from both sides directly, and you will get ma equal to minus 2kx, then a equal to minus 2k by m into x, then omega square means this coefficient, that is 2k by m. So omega equal to root over of 2k by m, but omega means 2 pi into natural frequency equal to root over of 2k by m. So natural frequency f equal to 1 by 2 pi root 2k by m. If time period is required, inverse of this is the time period, 2 pi root m by 2k. Question number 35. Two simple pendulums first of pendulum bob, mass m1, first of pendulum bob, mass m1 and length l1, comma, second of bob, mass m2, length l2. If m1 equal to m2, comma, l1 equal to 2l2, and vibrational energies of both are same. vibrational energies of both are same, then which is correct? Then which is correct? Option A. Amplitude of the second pendulum is greater than first pendulum. Amplitude of the second pendulum is greater than first pendulum. Option B. Amplitude of second pendulum is smaller than first pendulum. Is smaller than first pendulum. Option C. Amplitudes will be same. Option D, none of the above. Total mechanical energy is half m omega square capital A square for simple harmonic oscillator. Because total vibrational energy means kinetic energy plus potential energy. So that total energy are equal. It is mentioned in the problem. So for two oscillators, if I equate the vibrational kinetic energies, then I can write half m1 omega 1 square a1 square equal to half m2 omega 2 square a2 square. Now see, half can be cancelled. M1 and M2 can be cancelled because it is given that M1 equal to M2. So both are equal, so we can cancel. Okay, don't get confused that you cancel M1 and M2 different. In the problem, according to the problem, these two are equal. So I cancel this. So now it will be A1 square by A2 square, that is equal to omega 2 square by omega 1 square. For simple pendulum, time period we know T equal to 2 pi root over of L by G. T equal to 2 pi by omega. So from this we can write omega square equal to G by L. Okay, omega square equal to G by L. So from this we can substitute here A1 square by A2 square equal to omega 2 square. Omega 2 square means G by how much? First one, if L2 is L, L1 it is given in the problem that L1 equal to 2L2. L1 equal to 2L2. So I can write omega 2 means by G by L2 and this one is G by L1. So A1 square by A2 square will be equal to L1 by L2. But L1 by L2 is 2. Okay, so amplitude of the second pendulum is smaller than the amplitude of the first pendulum because it is coming A1 by A2 equal to root 2, which is obviously greater than 1. So A2 is larger than A2 is smaller than A1. So amplitude of the second pendulum is smaller than the first pendulum. So option B is correct. Problem number 38. A mass of 0.5 kg is moving with the speed is sliding with the speed a mass of 0.5 kg is sliding with the speed 1.5 meter per second on a horizontal smooth surface. On a horizontal smooth surface and collides with a nearly weightless spring of force constant 50 Newton per meter, of force constant 50 Newton per meter. The maximum compression of the spring would be option A 0.15 meter, option B 0.12 meter, option C 1.5 meter, and option D 0.5 meter. Option A 0.15 meter, option B 0.12 meter, option C 1.5 meter, option D 0.5 meter. How to solve this problem? If I use the equation of kinematics, that is v square equal to u square plus 2as, can we solve the problem? If I write if I use this equation, that is v square equal to u square plus 2a, then I can consider that final velocity 0, initial velocity is given, that is how much? So it is 0.15.
So 1.5.
Oh, sorry, 1.5 whole square, and it is producing retardation. The spring force is kx, which is producing retardation, where we consider x is the maximum displacement. Then we can write 2a means kx, k is also given, value of k is 50. By m, mass is given 0.5. X and another s is the distance traveled. So this is the acceleration term. Force means kx by another x. Can we solve from this to find the value of x? So this one. I write v equal to 0, u is 1.5 whole square minus 2 retardation into force by mass. Spring force is kx, minus is already written. Kx means k50, x is the displacement, x divided by 0.5 into x. Can we use this method to solve the problem? What is wrong in this method?
It will give equilibrium position, not maximum displacement.
In this equation, if I use, what is the problem in this equation? Which part of this equation is wrong? I cannot use this equation here because here A stands for constant acceleration, and here in place of A you substitute a variable, because it is the acceleration which is changing with position. So A is a variable acceleration, And in variable acceleration, you cannot use the equations of kinematics for constant acceleration, because v square equal to u square plus 2a is s equal to ut plus half at square, or v equal to u plus at. All these three equations are valid only for constant acceleration. It's a variable acceleration, so you cannot use this equation to solve this particular problem. Okay, because this acceleration is minus kx by m. Since x is present, it is a variable. So other option is to use the conservation of energy. Conservation of energy you can always use, whether acceleration is constant, whether acceleration is variable, or anything. Clear? So you have to use this form, half mv square equal to half kx square. That is, initially the kinetic energy of the ball is totally converted to spring's potential energy when the ball stops, and that is the maximum compression of the spring. Okay, so the ball is striking the spring with this kinetic energy. When the entire kinetic energy of the ball is gone, comes to zero, then it is totally converted to the potential energy of the compressed spring. So it will be half kx square, so compression of the spring will become maximum. So from this energy conservation, you can solve this problem. So this half cancel, so this x is now the maximum displacement. So x maximum will be mv square by k, its root. Just substitute the value, you will get your answer. So while dealing with SHM, be careful to use this v square equal to u square plus 2as and all these equations, because these are only valid for constant acceleration, and in SHM acceleration is not constant. It is changing the magnitude. So it is safe to use this one. Even in case of gravitation, it is safe to use the conservation of mechanical energy rather than to use the equation of motion or the kinematics equations, because g is variable at long distance above the earth's surface. If the distance height of the object is comparable to the radius of the earth, then g is variable. So it is difficult for us to keep track on g every time. So it is better to use this form of conservation of mechanical energy. Similar situation occurs in electrostatics also. There is also electrostatic potential energy, and again in that case, if the field is not constant, if it is in the problem it is mentioned that field is uniform, then okay, no problem. But if field is produced by a charge, and in this field another charge is feeling the repulsive force and moving, so its acceleration is variable, because as you move away from the charge, the force will decrease, which means decrease in acceleration. So acceleration will become variable. So it is safe to use conservation of energy again. But if in the electrostatic problem it is mentioned that particle is moving under constant electric field, then you can use the equation of kinematics as well. But conservation of energy is actually more vital, because it is used in both the cases. When acceleration is variable, when acceleration is constant, it is always applicable. But kinematics equations applicable in only constant acceleration cases, but not in variable acceleration. Okay, so substitution of value will give you the option A. Can any one of you explain why these two springs are in parallel combination?
Because in the same direction.
It's
In the same direction.
same direction and they are acted upon by same force. They are acted upon, no, not by same force, they are acted upon by same elongation. Same elongation and same compression. Means displacement is same. So that's why they are in parallel. Though it looks like they are connected in a line, but they are actually parallel, they are not in series. That is the main essence of this problem. Equal force means series combination. Equal displacement means parallel combination. You can consider here that if I pull this mass on this side, this first spring is elongated. So elongation of the first spring is x. So it is feeling a force F1 equal to minus K1 x. Now second spring is compressed by an amount x. So displacement is again x. So from the second spring, the force is F2 equal to minus K2 x. So this force, due to elongation of this spring, restoring force F1 acts in this direction. Due to compression of this spring, restoring force also acts in the previous direction. So restoring force in both the cases are on the same direction. First spring pulls it, second spring pushes it. So F1 and F2 are in the same direction. So net force of this mass F equal to minus K1 plus K2 into x. Now acceleration A equal to minus K1 plus K2 by m into x. So it shows that it is performing an SHM with omega square equal to K1 plus K2 by m. Then find time period. You can also think of that this one is an equivalent spring constant K equivalent K1 plus K2, means K1 and K2 are in, two springs are in parallel. Right now, two SHMs are given by x equal to a cos omega t, capital A cos omega t, and y equal to capital B sin omega t. If they superpose on a particle, then the trajectory of the particle will be see, this means that the two SHNs are perpendicular to each other. One is moving along x-axis, another is moving along y-axis. If so, two perpendicular SHNs superpose, what will be the resulting motion? It is similar to that finding the trajectory of a projectile. Eliminate t and find the relation between x and y. Just think of it as a problem of mathematics, trigonometry, just simply. Both equation, depending on time, you have to eliminate time to find the relation between x and y, irrespective of time. You have this type of problem in your class 10 trigonometry topic, mathematics. Some identity problems are there. Don't say that we have eraser and we will erase time. No. See, x equal to given a cos omega t, y equal to b sin omega t. Okay. You have to eliminate t. Many of you are thinking that we should divide this, and as a result omega t will cancel, this s and this s will also cancel. That is not the way. And then you should say that maintain a level of the NEET question. X, first write x by a, that is equal to cos omega t. This omega t is entirely like an angle, theta. Okay. Then y by b, it is equal to sine of omega t. Now many of you are trying to write this one as t equal to 1 by omega cos inverse of x by a. Okay, that is correct. But if you substitute it here, then it will be sine of cos inverse x by a. So from that, elimination will be more critical. So don't go in that way, because then sine of cos inverse, everything you have to calculate. Just simply squaring both sides of both the equations and add them. You will get your answer, that x square by a square plus y square by b square equal to 1. That is equation of an ellipse. So the particle will move in an elliptical path. If a and b are equal, then it will move in a circular path. See, some particular geometrical figures, you have to remember the equations of certain particular figures, like straight equation of a straight line, equation of a circle, equation of parabola, equation of ellipse, equation of hyperbola, equation of rectangular hyperbola. At least this 6 to 7 geometrical figures, their equations you have to remember. Otherwise, it is not possible always to find the equation and to solve, and frequently these equations will come. So how many figures I named? Straight line, or say pair of straight line, anything. Circle, parabola, ellipse, hyperbola, rectangular hyperbola. 6 figures. What is the general name of these equations, of these curves? What is the general name of these curves? Or how these curves we can generate? Don't say that we can draw this curve on the paper. How we can generate these curves? Their general name is conic section. Conic sections. Conic section word comes from sectioning of a cone. Suppose you have a solid cone. Okay? So from this cone, if you cut this cone in different way, all these curves will generate. So that's why all these curves are coming from the conic section. If you have a solid cone and you are allowed to cut this cone in different way. If you cut it horizontally, parallel to the base, then you will get a, if you cut it like this, then ellipse will be formed. Similarly, you can cut in different ways such that all these figures will be formed. So this, all these figures comes under a general topic called conic section. That is in your class 12 syllabus in mathematics. In coordinate geometry, there is a topic general conic section. Okay. So read these things carefully because otherwise it is very difficult to solve problems.